Hey guys, so welcome back in the PSM section. So now in this section we will be talking about the epidemiology. So we'll start from the epidemiology, but before going into the depth of the epidemiology, we should know some basic points about the epidemiology, right? So basically epidemiology, if you talk about, it's a quite a long topic, right? So you need to be with me. So I need your support from your side, but I promise you that once you will be finishing with these epidemiology playlist or epidemiology topics, then you will be very confident in answering all the queries regarding the epidemiology, right? So let's begin with the epidemiology now. So if you talk about the epidemiology, basically we'll try to first of all define the epidemiology, right? And my basic approach would be that first of all I will be trying to convey the basic concepts in this epidemiology, right? There would be some factual data here and there in the epidemiology, but at last we'll try to apply that knowledge in the MCQ section as well, so that you can get the idea that from which topics, right, the questions they are targeting basically, right? So with that, let's start with the basics of epidemiology. Okay, so first of all, let's define epidemiology. What is the epidemiology, right? Okay, so if you talk about the epidemiology, right? So what is the definition? Okay, so let's define the epidemiology. Fine. So basically it is a study of distribution. It is a study of distribution, determinants, right, of health related events and measures to control the disease, right? And measures to control the disease. Okay, what do I mean by that? Measures to control the disease. Okay, so basically what do I mean by that, right? So distribution means how the disease is actually spreading, right? Then determinants, what are the factors which are determining the disease basically, right? For example, the several kind of indicators I have told you earlier as well, right, in the previous sections. So first of all, we'll just study the distribution of the disease, determinants of the disease, and what are those factors which are used for measurement to control the disease, right? So this is basically the epidemiology, right? So as you will be going into this particular topic, you will gradually understanding that, okay, what is epidemiology, right? So with the definition, okay, it could be somewhat difficult to understand that what is epidemiology, but as you will be diving into the topic, it will be much easier for you to understand basically what is the epidemiology, right? Okay, so let's talk about further epidemiology. So here, if you talk about the measurement, I told you that measurement to control the disease, So basically we shall talk about some tools present over here, tools of measurement, right? Okay, tools of measurement. So here, what kind of tools I am talking about over here? Tools of measurement, right? So very important, 3 tools are present over there, okay, and very frequently tested in the MCQs as well. These 3 tools are, one is the ratio, second is the rate, and third is the proportion, right? Okay, so ratio, rate, proportion, let's talk about that as well. Fine. So first one is ratio. Okay, so very first one is the ratio. Let's talk about ratio first of all. Fine. So if you talk about the ratio, basically how we are actually defining the ratio in the mathematics. Also we are talking about the ratio. For example, so x by y, let's say that is the ratio, right? For an example, you are saying that x by y is the ratio, okay? But mind you over here that if you talk about the numerator and the denominator over here, right, generally this would be the numerator and it would be the denominator. There is, in the ratio, there is no relation between the numerator and the denominator. If you talk about numerator and denominator, usually there is no relation between them, right? And that is the ratio basically. After that, I will be talking about the rate, where the numerator and denominator are related to each other. Okay, I will give you the example as well. So let me just define what is the ratio basically. So ratio basically, it is actually consisting of, right, it consists only numerator and denominator numerator and denominator, right? But they are not mentioning about the time. Okay, I will tell you why I am mentioning about the time. So without time specification, right? Without time specification. Okay, whereas rate, I will tell you that there is a specification of time as well, right? So in the rate, I will tell you numerator, denominator both are present. Numerator and denominator, they are related to each other as well, and the time specification is also present in the rate. But for now, let me talk about the ratio. So in the ratio, we are talking about numerator, denominator. There is no relation between the numerator and the denominator, and there is no specification of time. Okay, very important for the MCQ's purpose as well. Let me just describe it with the example of some basic examples. Okay, for example, I shall take the example of maternal mortality ratio, right? Maternal mortality ratio. Fine. Let me just write over here as well. Maternal mortality ratio. Okay. In the maternal mortality ratio, okay, let me say number of maternal deaths, right? Number of maternal deaths, that is the numerator, right? Out of total population, right? Out of total population, or I would say total number of live births, right? Total number of live births, right? Multiplied by 100,000. Okay, that is the multiplicator factor over here. So what I can see over here, look at the numerator, number of maternal deaths. Okay, usually if I want to define this particular thing, that maternal deaths, so I should be having some comparing, some comparing number. For example, number of maternal deaths, okay, out of all the reproductive age group women or all the pregnancies out there. But I told you number of live births. So number of live births is regarding the basically infant and the neonates. But number of maternal death is regarding the mother. So there is no relation between that as such, right? So numerator and denominator, they are different entities over here. So that's why it is an example of maternal mortality ratio. This is an example of ratio basically. Okay. Some other examples, for example, doctor population ratio, doctor nurse ratio, nurse to population ratio. These, okay, sex ratio. These could be the other examples of ratio as well. Okay. So other examples, right? Like for example, sex ratio. Okay. Doctor nurse ratio, doctor population ratio. Okay, these could be the examples of ratio, right? MCQ, what will be the MCQ? MCQ will be like if the numerator and denominator are not related to each other, right? Your answer would be ratio. In the measurement of tools, okay, in the tools measurement, which of the following component will not talk about the time basically? Okay, usually it is ratio. Further, I will tell proportion can also be there, but that is the thing. Okay, fine. So ratio is done. Then now I'm moving on to the next entity, that is the rate. That is the rate. Okay. In the rate again, guys, let's say numerator is x, denominator is y, but now there is a relation between these two. There is a relation between these two. Numerator and denominator are having the association with each other, right? So let me write over here that it consists of numerator and denominator, right, with time specification, right? So that is the keyword over here, time specification. While in the ratio, I told you without time specification, right? So with time specification. Fine. Okay. Understood. With time specification. Okay. Now, second thing over here is there any relation between numerator and denominator? Yes, there is a relation between numerator and denominator. Okay. So, right. So there is numerator and denominator association present over there. So numerator is often a part of denominator, right? Numerator is often a part of denominator. I mean, there is some association between these two entities, numerator and denominator, right? Now example you can take. For an example, right? I told you maternal mortality ratio as an example in the ratio example. Here I am taking the example of maternal mortality rate. Maternal mortality rate. Fine. Maternal mortality rate. So in the maternal mortality rate, what we can talk about, for example, yeah, number of maternal deaths, okay, divided by total number of reproductive age females. Okay, total number of women reproductive age. Okay, multiplicative factor I am just keeping the same, that is 100,000. Okay, for the reference purpose. So here I am talking about numerator and denominator association. So for an example, numerator, number of maternal death out of those women who are having capability of getting the pregnancy, right? Women reproductive age, right? For an example, for about 15 to 45 years, right? That in that age group, how many females died, right? How many females died? So that is giving some association data, that is giving some relation between these two data. So that's how we are talking about this. Okay, so that is the thing. Time specification can be like number of females died in some community out of this much reproductive age group females in a year or in 2 years or in 5 years. Okay, they will mention the time, for example. So that's why time specification is present in the rate basically. Okay, so that is the difference between ratio and the rate. I hope you got the idea, right? Now I'm moving on to the next entity. So tools of measurement I am talking about in the epidemiology. First one I talked about the ratio, second one I talked about the rate, third I'm going to talk about the proportion now. So let's move on to the proportion. Okay, proportion. In the proportion we are saying numerator is always a part of denominator, right? Here I told you numerator is often a part of denominator. Here I am telling you numerator is always a part of denominator, always a part of denominator. Okay, and here it is always expressed in percentage, always expressed in percentage. For example, 40%, 50%, like that, always expressed in percentage. Very important. Okay, this is MCQ, always expressed in percentage, right? Fine. Now in the proportion, what could be the examples? Examples could be case fatality rate, right? Case fatality rate. I will talk about case fatality rate, don't worry, give me some time. So that is case fatality rate. Or prevalence, I will talk about this as well, right? Prevalence. So these are the examples of proportion, right? In the rate, okay, I can give you some other examples. Maternal mortality rate was the one example. Second example, you can take the type of like crude death rate, right? Crude death rate, it can be taken as example. Second, you can take the example of incidence, right? I will talk about that as well, because these are MCQs. Incidence is a ratio, rate, or proportion. What is your answer? Incidence, in that case your answer should be it is an example of rate. Okay, prevalence, it is an example of proportion, right? These are straight MCQs. So that's why it's very important to mention over here. That's why I mentioned them. So incidence is actually example of rate. Okay, prevalence is an example of proportion. Okay, direct MCQs. Fine. Now let's move further and let's talk about now the scheme basically. Yeah, so I was talking about the tools of measurement. We have talked about the ratio, we have talked about the rate, and we have talked about the proportion. Now let me just summarize all of these things, and I'm going to present you the scheme over here. For an example, if I will say that is numerator, if numerator is included in denominator, right? Okay, so I am just asking you, for example, is numerator included in denominator? Your answer could be yes, or your answer could be either no, right? So you might say yes, you might say no. Okay, in case your answer is no, so numerator is not a part of denominator, straight away your answer would be ratio, right? Straight away your answer would be Ratio. That numerator included in denominator? Is numerator is having any association with the denominator? I'm asking you. You might say no. You might say yes. If you are saying no, then it is a ratio. If you are saying yes, then I shall ask you one more question. That is time included in denominator, right? Is time included in denominator? So I'm asking you next question, is time included in denominator? Again, you might say yes, you might say no, right? In case if you say yes, right? Okay, you might say yes, you might say no. In case you are saying yes, then you are talking about rate. Over here, because I told you that time specification is present in the rate. In case you said no, then it would be prevalence. Sorry, it would be proportion. So, however, prevalence is a type. Prevalence is an example of proportion. So, it is a proportion, right? So, that is the case. Okay. So, numerator, denominator, no association, that is ratio. Numerator, denominator, there is association. It could be rate, it could be proportion, right? If there is any association between the numerator and denominator, it could be rate, it could be proportion, right? Now, is time specification is present over there or not? If time specification is present over there, then it would be rate. If not, then it would be proportion, right? So, that is the very simple scheme, right? That is very simple scheme for the tools of measurement, Okay, so I hope you are clear till now. Okay, I tried to make it as simple as I could. Now I am moving on from here, and now I am going to talk about the measures of morbidity. Remember in the previous sections, guys, right? In the previous section, I have told you about the mortality indicators and the morbidity indicators, right? I gave you the list of mortality indicators, I gave you the list of morbidity indicators, right? Now I shall go in bit detail in those indicators of the morbidity and the mortality, right? First of all, I will go into the morbidity and then I will tell you about the mortality as well. So in the morbidity, if you guys remember, I gave you the example prevalence, incidence, right? Those were my initial choices in the morbidity indicator. So incidence and prevalence, right? So examiners are testing these two variables very frequently, right? So we need to talk about this. In the morbidity section, I'm going to talk about these incidence, prevalence, okay, these kind of things, right? So are you with me? So let's start with that. So now I'm going to talk about measures of morbidity, right? So I'm going to start with the measures of morbidity. Okay, fine. So very first I'm going to talk about the incidence, right? Okay, however, incidence is an example of ratio, rate, proportion. Rate, very nice. Prevalence is an example of ratio, rate, proportion, right? Very nice. Okay, fine. So measures of morbidity, basically it indicates what, guys? I told you mortality, it was telling you about the death or the mortality, very simple. Morbidity is an indicator for sickness, disease, right? Illness. So this is actually identified by the morbidity indicator, right? So it is actually telling what? It indicates morbidity, it indicates any kind of illness or sickness, right? Or any kind of disease, basically, right? That is the morbidity. Now I'm gonna just start with the first one. That is your incidence. Okay, that is your incidence. Basically, what is incidence, guys? Incidence basically the number of new cases which are coming in the population, right? Very, very easy, guys. Look over here. For example, this is some community. Here in this community, there is some population. Okay, I will add some cases over here. Very, very simple. I will add, let's say, 500 cases of dengue. 500 cases of dengue virus. I have just, they have just introduced in this community. So what is this, guys? This is the incidence. This is what? This is the incidence. This is the incidence. So number of new cases in some community, in some population, that would be incidence, basically. Very, very simple, right? Number of new cases per unit time. I told you in the previous section also. Okay, fine. So incidence, basically, I'm just defining over here as well. So it is the number of new cases occurring number of new cases occurring in a defined population, in a defined population, right, over a period of time, okay. So there should be no confusion. Fine. Now there is a formula, so incidence is, okay, incidence is number of new cases, right? So number of new cases of a disease, number of new cases of a disease in a specified period of time, in a specified period of time, divided by total number of cases who are at risk. So population at risk, okay, multiply it with 1000. Fine. So very easy, guys. Number of new cases which has been introduced in some population over a period of time divided by total number of population who are at risk, multiplier will be the 1000 into 1000, right? For an example, I will give you a very simple example over here. Okay, there is some community. Okay, this is the community. I added 500 cases of dengue. I added 500 cases of dengue virus. Okay, and let's say here the population, was 50,000, right? This is the population is 50,000. Okay, so in this case, what will you say, right? Let's apply the formula, guys. Incidence equals, okay, so this was the question, this became our question now. Okay, so what is the question, guys? What is the question? I'm just writing in this particular box. Okay, question is very easy. It says that there is a population of 50,000 people, population of 50k, okay, population of 50,000, and the dengue cases comes in, that is 500 new cases of dengue came in that population, right? So over here I can say that incidence would be total number of new cases, right, in a specified period of time, that is 500, divided by population at risk. So 50,000 people are at risk, so 50,000, multiplier will be the 1000 over here, right? So what will be the answer? 500 divided by 50. So your answer became over here, that is the 10. Okay, 10. What would be the 10? 10 per 1000 year. Okay, so 10 per 1000 years. Our answer became 10 per 1000 per year. Okay, this is an example of rate. Incidence is an example of rate. It is not a proportion. Proportion is expressed in percentage. Rate is not expressed in percentage. So do not say that it is 10%, 20%, 30%. No, that is proportion, right? This is incidence. Incidence is an example of rate. And how we are actually telling the rate? That is per 1000. Okay, so over here 10 per 1000 per year. Fine, simple, guys. Okay, fine. Now I'm moving on to some important points of the incidence again. So incidence, if you will further talk about, then it is generally it is used for the acute illness diseases, not for the chronic, acute illness. So incidence, it is used for acute illness. Okay, it is used for acute illness. Second point over here is it tells about the effectiveness. It tells about the effectiveness of healthcare system, effectiveness of healthcare system and the progress and its progress. Healthcare system and progress. Fine. So what is incidence, guys? Total number of new cases introduced in some particular population over a period of time, right? It tells us about the effectiveness of healthcare system and its progress, right? Generally we are using the incidence for what? We are using the incidence for acute illness, right? Then we are having some special types over here, right? What are the special types? So we are having some special types, right? Special types in what? Incidence. So what are the special types? Special types are, guys, first one is your, okay, A, right? First one is your attack rate. Okay, this is your attack rate. Okay, attack rate. Second one is your, okay, just mentioning over here, second one will be your secondary attack rate. Secondary attack rate. Okay, in short we are calling that as SAR. Okay, SAR. So what is attack rate, guys? Attack rate is very simple. It is used when there is a risk for limited period of time. Okay, when there is a risk, okay, there is a risk for limited period of time. What risk I am talking about? Risk of having the disease. Okay, risk for having the disease for limited period of time. Okay, limited period of time. Okay, there is a formula for this attack rate. I am just denoting it as AR. Okay, just denoting this with AR, attack rate. Formula is attack rate is number of new cases, because it is an example of incidence. So we are talking about the new cases. Number of new cases divided by total population at risk. Total population at risk multiplied by 100. Total population at risk multiplied by 100. Okay, I will take the example. I will take one example to make it very easy for you guys to understand what is the attack rate basically. Okay, so example would be like, for an example, 100 people are there. Okay, they went to some party, right? So just writing the example so that you can understand, right? 100 people went to party, right? 100 people went to party. Out of those 100 people, 50 people ate contaminated food, right? And out of those 50 people, let's say 25 people developed food poisoning. Okay, so 50 people ate contaminated food. This could be your question as well. Contaminated food, right? Which results in what? Which results in developing 25 people. Due to that, 25 people developed food poisoning. 25 people developed food poisoning. Okay, food poisoning. So here I can say that 25 out of 50, right? So total cases who were contaminated, total persons who were contaminated over here, that was 50. Out of those, food poisoning, right? That was food poisoning. Okay, 25 persons developed food poisoning. So 25 divided by 50. So what will be the attacking rate over here? Attack rate, that is a 25 divided by 50 multiplied by 100. Okay, so what will be your answer? That would be 50, right? That would be 50. Now, incidence, it is an example of rate. But over here, these special types of incidence, which is the attack rate and the secondary attack rate, these both attack rates and the secondary attack rates, they are expressed in percentages. That is the trick over here, guys. So they are expressed in percentages. So over here, I will write 50%. So they are expressed in percentages. Always remember, they are expressed in percentages. Okay, however, incidence is not expressed in percentage. Incidence simple is actually expressed per 1000 per year, like that. Okay, why per year? Because I told you there is a time specification in the rate. Okay, I hope you are getting some knowledge out of this. So now attack rate is done. Now I'm just moving on to the secondary attack rate. Okay, let's just move on to the secondary attack rate. Secondary attack rate is like, first of all, before understanding the secondary attack rate, I will tell you two things over here. One is the primary case and another one is the secondary case. Okay, let's try to understand between primary and the secondary case. Primary case is the one who gets the disease at very first place, right? For example, there is a family. Okay, there is a family of having the 6 members. Out of 6 members, only one member is having, for example, what? One member is having the, let's say, dengue fever, dengue virus, or one person is actually COVID positive, right? Out of those 6 members, one person is COVID positive, right? Other members are fine. After 4 days, what happened? 2 more members got COVID positive, right? So what is this case? Here, initially, you had first case, the first person was COVID positive, one person only was COVID positive out of 6 members. This is the primary case. Now, due to this primary case, 2 more members got contaminated and now they are also COVID positive. So those 2 new persons who got contaminated and now they are COVID positive, those 2 cases will be the secondary case. So I hope you got the difference between the primary and the secondary. So there is a primary case and there is a secondary case. Now I'm coming to the secondary attack rate. Okay, secondary attack rate tells in itself that the number of people who are exposed in the disease, right? The number of persons who are developing the disease within the range of incubation period. Okay, following by the exposure from the primary case, right? So that is the thing. So secondary attack rate, if you talk about the definition part over here, definition part is that number of, because if you will look at the definition at first place, it might be confusing for you, right? So look, number of, this is that number of people who are exposed. I'm talking about number of exposed people, right? Number of exposed people within getting the disease, developing the disease within incubation period, followed by exposure to primary case. In simple words, guys, okay, that's what the book says, but in a simple word, due to that primary case, some other persons became the secondary case, right? So first of all, one person was infected, due to that person, some 2 more person or 3 more person got infected. Now these are the secondary case, that person was the first primary case. Okay, so here we are talking about a secondary case, right? So followed by primary case. Are you understanding me? I mean that primary case was infected. Now due to this primary case, now these 2 other peoples who became the secondary case, now they are also infected. Okay, so they are talking about that in the secondary attack rate. Okay, so if they develop disease, this is what the secondary attack rate. Okay, I'm just taking the example again, guys. For an example, again same example, 6 members are present in a family. Out of those, 1 member is COVID positive. After 4 days, okay, or after 3 to 4 days, what happened? Now 2 more members are COVID positive now. 2 more members are COVID positive now. Okay, so what would be the secondary attack rate in this case, right? Now to actually, if you talk about secondary attack rate, there is a formula. Okay, so let's talk about that formula also, how you can actually solve this question. So they are asking you, what is the secondary attack rate? What is the secondary attack rate? Okay, so secondary attack rate is having formula that number of exposed persons developing disease by total number of exposed persons multiplied by 100. Okay, so here if I will apply this formula, secondary attack rate, so number of exposed person developing disease over here, these are how many numbers? These are 2 more numbers, right? So 2 more members. So here I would write 2, total number of exposed persons. Okay, one was the primary case and another one with the secondary case, so that became 2 plus 1, 3 multiplied by 100, right? 2 multiplied by 3, 100. Okay, approximately 0.18 into 100, so it became what? 18%. Always expressing percent, right? So attack rate, secondary attack rate, both of them are expressing percentage. Okay, I may define one more definition or one more formula out of this, right? What will be the formula? Secondary case divided by primary plus secondary case. Okay, so I might write secondary attack rate formula so that you can actually solve more questions. Secondary case divided by primary plus secondary cases, okay, multiplied by 100. That can also be the formula, right, which you can actually derive from this particular formula, right? If this formula is confusing for you, then you can remember this formula also and you can actually solve your answers. Okay, usually they might actually ask you these kind of questions, that for an example, out of 10 members or out of 10 people, these many got the infection from these many cases. So first of all, you need to identify primary case and the secondary case. Then you can easily solve the answer. You can easily get the secondary attack rate. Okay, I hope you are clear with this now, guys. And now I am moving on to the prevalence part. Okay, I have talked about the incidence, I have talked about the types of incidence, I have talked about the attack rate and the secondary attack rate. Now I am moving on to the prevalence, which is also a very important measure of morbidity, right? Remember, we are talking about the morbidity over here. In the morbidity, I have talked about the incidence. Now I am moving on to the prevalence part. Okay, so let's talk about the prevalence now. Okay, now let's talk about the prevalence now. Second over here would be the prevalence. So this is also very important, prevalence. Now it is a type of rate, ratio or proportion? It is a type of proportion. Very nice. So it is a proportion basically. So let me define you. It is a proportion of all the cases. Proportion. Look, incidence was total number of new cases introduced in some community over a specific period of time. What is proportion, guys? Number of new cases plus number of old cases. If you will combine them, became prevalence. Simple. Number of new cases, incidence. Number of new cases plus old cases became prevalence. So prevalence, basically it is a proportion of all the cases. It is a proportion of all the cases. Proportion of all the cases, right? I mean old cases plus new cases. Okay, always expressed in, guys, it is an example of proportion, so always expressed in percentage, right? 30%, 40%, 50%, 55%, 60%, like that. Okay, always expressed in percentage, right? Okay, fine. Now if you talk about the formula of the prevalence, we can say that prevalence equals number of total cases, old cases plus new cases, divided by total estimated population multiplied by 100. Okay, in the incidence the multiplier was 1000. Here I am talking about multiplier as 100. So total number of cases, guys, total number of cases, I mean old plus new, divided by susceptible population or the estimated population, okay, multiplied by 100. So this became your formula for the prevalence, guys, right? This became the formula of your prevalence. If the question will come, you can solve very easy, right? For example, this much old cases they are giving you, this much new cases they are giving you, and they are asking you what would be the prevalence, right? So it will be very easy for you guys, right? You can actually apply the formula and get the answer. Okay, fine. Now next point is the types. I told you the types of incidence also. What were those incidents? Attack rate, secondary attack rate, but they were expressed in percentages. Here I'm going to talk about the types of the prevalence as well. So here let's talk about the types. Okay, in the types we shall talk about the two types, very important. Point prevalence. First is point prevalence. Okay, and the second one we shall talk about the period prevalence. Okay, generally point prevalence is that whatever diseases, okay, are present at a given time. Okay, disease is present at a given time, okay, and period prevalence is that these diseases which are present within a range. Okay, diseases which are present within a range, diseases present within a range of time, okay, understood? Yeah. Now look over here, period prevalence I told you, and I have talked about the point prevalence also, right? Point and period. So let me give you an example over here. For example, let's say okay, let's say this is 1 month. Okay, this is 1 month. Let's say this is the 1st of January and this is the 31st of January. Okay, in between the 1st of January and the 31st of January, whatever diseases are present over here, right? Whatever number of diseases are present over here in this particular time range, I would talk about the period prevalence in that case. Okay, I will say that this is the period prevalence. But whatever diseases are present at this point of time, for example, or at this point of time, for an example. Okay, for example, number of diseases are actually running from backward, okay, from previous year. For example, number of diseases who are actually running from previous years, okay, and they might actually extend into the February as well. Okay, so whatever is coming in this and touching this particular date, that would be the point prevalence. I'm talking about point prevalence. Okay, so whatever diseases actually are touching this point of time, 1st of January or 31st of January, if I'm saying I actually need at this point, so that would be your point prevalence. Whatever diseases are present from here till here, okay, I mean in between 1st to 31st Jan, that will be the period prevalence, okay, because I'm talking about the period. Okay, fine, I hope you got the idea. Now I'm moving further, and now I'll be talking about the measures of mortality. But before that, one more formula. I have talked about the incidence also. I've talked about the prevalence. One more formula of the prevalence, because sometimes they might ask you this. So prevalence, one more formula is prevalence equals incidence multiplied by time duration, or you can say mean duration. So this is also one more formula. For an example, they might say that this is the incidence, or for example, they say incidence of a cholera is 8 per 1000, okay, in a 2 years period of time. So 2 years period of time became this mean duration, and 8 per 1000 became the cholera incidence. So 8 per 1000, or if they might ask you the prevalence over here, so 8 per 1000, 8 by 1000 multiplied by 2 years, which they have talked about in the MCQ, right? So 8 per 1000 multiplied by 2, in that case, whatever will be the answer, that will be your prevalence. Okay, so I just give the example. These kind of questions they might ask you. So in that case, you might actually use this formula. Fine. Now I'm moving further, and now I'm going to talk about the measures of mortality. So we have talked about the measures of morbidity. Now I'm coming to the measures of mortality. So several kind of death rate I told you in the last lesson also, that we might be having the age specific death rate. Okay, we might be having the case fatality rate, we might be having the crude death rate. Whatever death are coming, actually they were actually a part of mortality indicators. So now I'm going to talk about and mention some of those indicators over here. So measures of mortality now I'm going to talk about. So let's say measures of mortality, let's talk about them as well. Measures of mortality. Okay, measures of mortality. So now if we talk about measures of mortality, okay, so now if you talk about the measures of mortality, we shall talk about the death over here, or we shall talk about the mortality. So what it indicates mortality or death, okay, which we have talked about in the previous sections also. So now I'm going to introduce you some of the types over here. However, we have talked about that in the previous section also. For example, I want to introduce the formula actually for these ones. For example, first of all is the crude death rate. Okay, so what is the formula of crude death rate? Crude death rate says the total number of deaths divided by mid-year population, multiplied by 1000. Okay, what do I mean by mid-year population, guys? Mid-year population means that here I'm talking about that the population taken from 1st of July to 30th of June of next month, right? So population taken from 1st of July to 30 June, okay, to 30th of June, okay, every year, that is your mid-year population. So total number of death by mid-year population multiplied by 100, okay, multiplied by 1000, that would be your crude death rate. Okay, so already this was your MCQ. Okay, and what is the mid-year population? It starts from which date? 1st of July, that is also your MCQ. Second is your age specific death rate. Okay, so age specific or cause specific. So first let me talk about the cause specific also. cause specific death rate. Okay, because here also why I am taking this first, because I will talk about age specific also. I am taking this first because in the denominator mid-year population is coming over here as well. So cause specific death rate. So here answer became very simple, guys, again. So now total number of what? Total number of death. This was your crude death rate, but here in the cause specific death rate, death happened due to some specific cause. That would be the numerator over here. So death due to some specific cause, as the name suggests, the cause specific means death due to some specific cause. For example, death due to dengue fever, death due to COVID virus, death due to some typhoid, right? Death due to coronary artery disease, or due to some other disease, for example, stroke, right? So death due to some specific disease, death due to specific cause, right? Death due to specific cause by mid-year population multiplied by 1000. Okay, so that became your cause specific death rate. Okay, let's move on to the next one. That would be your proportional mortality rate. In the proportional mortality rate, we are seeing that proportional mortality rate. In the proportional mortality rate, the formula is death due to a certain disease by total death. Death due to a certain disease. Death due to certain disease. For example, death due to COVID virus, okay, or death due to coronavirus. Death due to certain disease by total number of death. Here we are not talking about mid-year population. We are talking about total number of death. Multiplier will be 100 over here in this case. Okay, so multiplied by 100. Now fourth one is, these all are your MCQs. That's why I'm just mentioning over here the formulas. So proportional mortality rate. After that, we shall talk about the case fatality rate. Case fatality rate. Okay, case fatality rate. Here the formula is death due to certain disease. That will so the numerator would be like proportional mortality rate only, death due to certain disease, but the denominator became over here is total cases of that disease. So death due to certain disease, death due to certain disease by total cases of that disease, total cases of that disease, right, multiplied by 100. Okay, so that is your case fatality rate. Now case fatality rate, very interesting thing over here is case fatality rate. It is, however, the rate is coming over here, case fatality rate, but it is not an example of rate. Case fatality rate is an example of proportion. So if somebody will be asking you how it will be expressed itself, so it will be expressed as percentage. It is an example of proportion. Okay, and I have mentioned this in the proportion example only, that proportion is an example of, so case fatality rate is an example of proportion. And one more example I gave you over there, that was prevalence. Prevalence is also an example of proportion. In the special types of incidence, I have talked about the attack rate and the secondary attack rate. Those two were also an example of proportion. Okay, now let's talk about fifth. Okay, so let me just document this info over here, that it is a proportion. Okay, it is an example of proportion, so expressed in percentage. Fine. Now let's move on and talk about next rate over here. But before that, let me mention one more thing, that it is an indicator of virulence. Virulence means killing power of some disease, right? For example, we saw that virulence was very high as far as COVID-19 was concerned, right? So killing power of that coronavirus was very, very high. So it also indicates, so case fatality rate is a very important rate. Okay, however, it is an example of proportion. So it indicates the virulence of a disease. Indicates virulence. What is virulence? It is a killing power. Okay, virulence is a killing power of a disease. Okay, so it indicates virulence or killing power of a disease. Very, very important point. Fine. So it indicates virulence of a disease. Okay, fine. Now let's talk about the next rate over here, that is the case survival rate. So if you talk about case survival rate, I will take the next page. So fifth one would become the case survival rate. Okay, in the case survival rate, if you talk about the formula, basically number of survivors in a certain disease. For example, there was a patient who actually survived from coronavirus, right? Okay, so number of survivors due to some certain disease, number of survivors, okay, in a certain disease, number of survivors in a certain disease, okay, that is the numerator. Denominator would be total cases of that disease, total cases of that particular disease, multiplier would be 100, okay, multiplier 100, that is the case survival rate. So number of patient who survived the coronavirus divided by total number of persons who was infected with the coronavirus multiplied by 100. Just an example of COVID I just talk, if you talk about the case survival rate, right? So next important term over here that we shall talk about in the basics part, that is the standardization. Okay, standardization. So what is the standardization? Basically we are comparing two populations over here. For an example, you know, it is this factor is used to compare the two populations with different age composition, right? For an example, this is one population, or this is one country. Let's say this is the another country. Okay, this is A, this is B, right? So in the A there is some population, in this community, in this portion there is some population, in the B also there is some population. Okay, now let's say here we shall say that number of adults are more, and over here let's say number of children were more. So different age groups are there, right? So if I will say that if I will compare these two proportions with two different age groups, that will be called as standardization, right? Standardization. Now in the standardization we are having two types, one is direct and one is indirect. Okay, so in the direct what we are saying is, if I will mention about the age specific death rate, for example I will compare population A and population B, but I will compare the same age group. For example, adult age group in the population A, adult age group in the population B. So I am comparing the same age group in different population, that is the direct standardization. If I will compare the different age group in different population, for example in the population A I am comparing the adults with the children in the population B, that would be the indirect standardization. Okay, so I hope you got the idea. So basically in a nutshell, standardization says that it is used to compare two populations. Okay, it is used to compare death rate. Basically it is used to compare death rates in two populations with different age group. Okay, with different age groups. Okay, so number of death rate I am comparing basically in two different population. Okay, if I am having the age specific data in my hand, then it would be the age specific death rate. If I am having that particular count, then it would be the direct standardization. If I am not having the age specific death rate, for example number of patients who died were adult, okay, and those were around 1 lakh people. So 1 lakh adults, okay, have actually died in the population A group. Okay, and on the other hand we are having the children who have died. For an example, 10,000 children have been died in the population B age group. So I am comparing the different age groups in these two populations. So that will be the indirect standardization. Fine. So in the types we are having, first is direct. Okay, one is direct and another one is indirect. Okay, so we shall compare over here. In the direct we are talking about that age specific death rate, age specific death rate of the comparing population. Okay, of comparing population are available with us. Comparing population are available. Right? On the other hand, in the indirect, age specific death rate in the population, age specific death rate of comparing population is not available. Okay, I gave you the example as well. I hope you got the idea. Are not available. Fine. So that is your difference between direct and indirect standardization. Okay, usually they ask you what is standardization, definition of standardization, or what is the direct one, what is the indirect one. Okay, so you can answer very easily those type of MCQs, right? Now in the indirect one, we generally talk about the standard mortality ratio. Okay, standard mortality ratio, that is your SMR. If you will abbreviate this, that is your SMR, standard mortality ratio, right? In the standard mortality ratio, what we are seeing that, okay, that is the ratio of expressed death by the observed death. So it is the ratio of expressed death to the observed death multiplied by 100. So expressed death, okay, because it has been asked once in the MCQs, by standard mortality ratio, basically this is the, okay, this is not the expressed death, actually it is the observed death. Okay, so correct it over here, it is the observed death by the expected death. Okay, for an example, you were expecting that some mass casualty happened. Okay, there was some bomb explosion, and due to that bomb explosion, what happened is that you were expecting that almost around 10,000 people might have died. Okay, but in reality you came to know that observed death which were found, that was around 12,000, right? So you were expecting the 10,000 death from that bomb explosion, but now you saw that when the news came out from there, okay, after a few days, and they found out that even more than 10,000 people have been died in that particular bomb explosion. So number of observed death over here will be the 12,000, and number of expected death which you were expecting over here, that was 10,000, right? So 12,000 by 10,000 into 100, that would be the basically standard mortality ratio. Fine. Okay, so observed death by expected death multiplied by 100, that would be your standard mortality ratio. Okay, I hope you are clear with that. Fine. Now at last we shall talk about some factual questions. For example, fathers, basically sometimes they might ask you. Okay, first one, father of medicine. Okay, you shall answer me while I am writing other questions. Second question is father of surgery. Okay, father of Indian surgery. Okay, father of Indian surgery. Fine. Then I might say father of public health. Okay, and my next question is father of modern epidemiology. Father of modern epidemiology. Okay, so you might answer me yes. So what is your first answer? Father of medicine, Hippocrates. Okay, father of Indian surgery, Sushruta. Okay, father of public health, cholera. Yes, and father of modern epidemiology, John Snow. They might be your MCQs. Okay, they might not be your MCQs, but they have been asked previously, so I have just mentioned them. Okay, so that was about the basics of epidemiology, and in the next chapter I will be talking about the components of the epidemiology, basically. Okay, so the description part basically of the epidemiology I will talk about in the next section. Okay, so I will be talking about, now I shall talk about in the epidemiology section, I shall be talking about the descriptive epidemiology, I shall be talking about the analytical epidemiology, and I shall be talking about the experimental epidemiology in the upcoming section. So stay tuned and I will see you in the next chapter. Thank you so much for sparing your time with me in this one. Thank you.